Welcome back. We've just looked at combustion as a type of non-equilibrium system, and another reaction we're going to look at today is photosynthesis as a non-equilibrium reaction. So let's go. So we've already looked at combustion and how it's an exothermic reaction and is spontaneous due to its Gibbs free energy value. Today we're going to look at photosynthesis in terms of entropy and enthalpy and its Gibbs free energy. So photosynthesis is an endothermic reaction requiring some energy from the surroundings to be absorbed by the system so that the reaction can take place. And it takes place in the chloroplasts of those plant cells. It requires UV light for that reaction to take place to get that energy. We also need chlorophyll to be present, and it acts as a catalyst for this reaction to occur. Now, photosynthesis, you can see here in our reaction, requires water, carbon dioxide, and also our glucose, and produces our water. So this is just a summary. This equation here is just a summary of the reaction that occurs. But in actual fact, it's a complex series of reactions involving multi-steps. And we don't need to know this in detail. But what ends up happening is we have applied Hess's law to come up with the end reaction. So what can we say about the entropy for photosynthesis? So again, if you look at the reaction that we have, both sides have got gases. Both sides have got 6 moles of carbon dioxide on one side and 6 moles of oxygen on the reactant side. So we're not getting a change in our entropy in that regard. But if you actually have a look, the reactant side has a liquid, whereas the product side has a solid. So you can see there that the liquids have more entropy than the solid does. So the reaction is occurring in the reverse direction, and so it's therefore an endothermic reaction as the entropy is decreasing. But what can we say about the enthalpy? In this case, it's positive. If the change was negative, it would be an exothermic reaction, but in this case it is positive because it's requiring energy from the system, which is the sun, for the reaction to occur. So as I've said before, it's a series of steps. It's not just a one-step reaction, and it's not a reversible reaction. So it can never reach that equilibrium. So if we have a look here and do the Gibbs free energy calculations like we did for combustion, we would see that Gibbs free energy is a positive value there. And because it's positive, it's non-spontaneous and it requires an external supply of energy for the reaction to occur. Thanks for joining me today, and we'll have a look at this a little bit further in our lessons.